All right, this video is on impulse and collisions, particularly calculations with inelastic collisions because they're a little simpler for this class. So we look at this first problem involving impulse. We've got a 500 Newton force acting on a 10th kilogram golf ball. Club's in contact with the ball for 100th of a second. We want to know the magnitude of the impulse and then the change in the velocity. So for that first one, we're going to calculate the impulse. And this is going to be equal to the force times the change in the time. That is the time it's in contact. So you're going to have your 500 Newton force times 100th of a second. So we're going to say 0.01 seconds, or you're going to get 5 Newton seconds. Now, to get the velocity, what we found is that the impulse is also equal to the change in the momentum, P, for the object when it struck, which is equal to the mass times the change in the velocity. And that will be equal to our 5 Newton seconds. To get the units to work out, so you can see things cancel, it'll be 5, and then we'll split that Newton up for a kilogram meter per second squared times a second. Seconds will cancel. So essentially, our change in our velocity is equal to our 5 kilogram meter per second divided by 1/10 of a kilogram. Kilograms are going to cancel. We're going to get 50 meters per second, which is pretty fast for a golf ball, but nonetheless. So we're going to look at a second problem, which involves conservation of momentum and a more or less inelastic collision. 100 kilogram fullback moving downfield at 5 meters per second collides with a 75 kilogram defensive back running at 4 meters per second in the opposite direction. So we're going to give that 4 meters per second a negative sign to indicate direction. They hang on together, and the two players move together after the collision. What's the momentum of each player, momentum of the system, and what's the velocity of the two players after the collision? So momentum of the fullback will be the 100 kilograms times the 5 meters per second, because it's mass times velocity. And so you get 500 kilogram meter per second. And then for the defensive back, you got 75 kilograms times 4 meters per second, which will give us 300. This will be negative, so this will be negative as well, because it's acting in the opposite direction. Now the momentum of the fullback is bigger because he's running a little bit faster and is certainly heavier. The total momentum of the system will have a vector of 500 Newton seconds going this way and 300 Newton seconds that way. So what's the difference? 200 Newton seconds. So it's going to be 500 Newton seconds minus 300 Newton seconds, where the net momentum then would be the addition of those two vectors, which would be a positive 200 Newton seconds, which means we're going to go in the direction of the fullback just a little bit. So if that's the net momentum, what's the velocity of the two players afterwards? So our momentum total is equal to the mass times the velocity. Now we know the momentum, we know the total mass because it's the two put together. So velocity is going to equal the total momentum divided by the total mass of both players together. So 200 Newton seconds divided by 175 kilograms. will give us 1.1 meters per second. And that would give us our answer. This last problem talks about train cars coupling an inelastic collision. That is, car 5 is going to come up and actually couple with car 4, and then they'll all move forward, but at a slower rate than car 5 was initially. So all the rail cars are the same mass, so each car is 20,000 kilograms. The fifth car, with the same mass, velocity of 15 meters per second, it collides with the other 4 cars. What's the initial momentum? That is the momentum of car 5. It's going to be 20,000 kilograms. And it's moving 15 meters per second. So you're going to say 20,000 times 15. Or you're going to get 300,000 kilogram meter per second. Now, what's the velocity of the coupled cars? What we need to realize is that the initial momentum is equal to the final momentum. We're just going to slow down but have more mass. So essentially we're going to say mass total times velocity final is equal to that 300,000 kilogram meter per second. So our final velocity will equal 300,000 kilogram meter per second divided by the total mass. So you got 5 cars at 20,000 kilograms each, which will give us 100,000 kilograms, which means it'll slow down to be 3 meters per second. All right, this has been a brief tutorial on impulse and collisions and conservation of momentum.